Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
Aw, I am Dr. Moiya McTier, a friend to the universe, and an astrophysicist and a folklorist, and one half of this hosting super team.
And I am Corinne Caputo, the other half of this hosting super team. I am a writer, a comedian, and a friend to the universe.
Hell yeah, you are.
Uh-huh. Where are we recording from today, Moiya?
Okay, so this episode is actually coming out right after my birthday. So we're recording in the time when I'm preparing for my birthday, and I needed to get my hair done. So we are recording today at a hair salon. I'm here to get a deep conditioning steam treatment and a little trim just to make sure my ends are healthy, because I already love the natural style of my hair.
Yeah. You got to treat yourself on your birthday.
You really do. I want to look good. And I just love being in this environment with all the chatting, all the like the sound of the hair dryer. It just brings me back to my childhood.
It's very community oriented, the hair salon, and I love it.
It really is. Corinne, what are you getting done today?
Oh, okay. I'm going to just get a trim. I'm never as adventurous as I want to be for a haircut. So when Trump got elected in 2016, I cut my hair real short. I think it was the only time I've ever done that. It was definitely I suddenly need control quickly. I'm gonna get a short haircut. It did look cool, but it's long again, and maybe I'll get layers.
I think you'd look great with layers.
Yeah, maybe a curtain bang.
Ooh.
We'll see.
Well, I mean, is that a cry for help, Corinne? The bangs?
Well, I feel like curtain bangs are if you want to dip your toe in something adventurous, but you're not ready for the full across. They grow out better than other bangs.
Oh, okay. I didn't know that.
Maybe I'll ask for their opinion. They always know better than me.
They do. They're so wise. They know everything. When you said you cut your hair just to gain back some semblance of control, it reminded me of when I used to get really stressed in college and cut my hair in these fits of rage and sorrow. And my roommate would get so concerned. But the last time I did that was right before my senior year of college. I have not taken scissors to my hair in angst since.
It's a very toddler-like reaction to life.
Yeah.
Where you're like, oh, here's scissors. Here's a little bit of freedom. No one's looking at me.
The things you do as an adult to assert your freedom.
Yeah.
No, it's a really cathartic feeling, like literally getting some weight off of my shoulders from my hair. Now I just go get stress tattoos.
Yes. Oh, totally. That's like that's a much more fun and permanent solution.
Exactly. It's like, oh, instead of temporarily chopping off something that naturally comes out of my head, why don't I just go pay a lot of money to have a stranger, stab me millions of times and permanently alter my physical form? That sounds great.
There's a tattoo shop in Williamsburg called Ephemeral, and they do like long-lasting temporary tattoos.
How does that even work?
I don't know. I feel like it's got to be a henna type ink, but I don't know how long it lasts. But I liked that it was called Ephemeral. I thought that was a Williamsburg name, and it fits the space.
Absolutely. Okay, so while we're getting our hair done, let's talk about how astronomers search for extraterrestrial life. This was a topic that you were like, Moiya, I want to know how we find aliens.
I really need to know about this. Yeah, well, not obviously, but I have no personal connection to aliens. So beyond
that's obvious to me.
I do. I used to watch a lot of pre-streaming, the cable era of trash TV, which was largely, and this is still true, it's largely unsolved mysteries or people talking to camera and saying, like, this is when I was abducted. And those are always the shows that I would just gobble up.
I think I watched Ancient Aliens like once.
Oh my gosh.
And I was like, never again.
I love the ones of people talking to camera and they're just like, they poked my belly button a few times.
That's just a dream. You just had a dream of someone poking your belly button.
But I'm sitting there and I'm like, oh my God, they did that.
But I mean, to an alien from a species that doesn't reproduce the same way we do, they might not have ever seen a belly button. And they're like, ooh, why do they have a feed hole here?
Why do you all have this trait? Yeah, exactly.
Okay, so I have to say this up top. Astronomers have not found evidence of extraterrestrial life elsewhere in the universe or here on Earth. Let's just keep that all in mind. Everything we're talking about in this episode is how astronomers are trying to find proof or evidence of extraterrestrial life, but we haven't found it yet.
But we could.
They would take my astronomer's card away if I didn't say that. Because so many times I do interviews or I do talks, and someone from the audience will ask me if I believe in aliens. And I do think they're out there. I'll be very upfront about that as well. But I know that astronomers haven't found evidence yet because we're all such gossipy bitches.
It would come
we
right
wouldn't
out.
be able to keep the secret. I remember back in, I want to say like 2017, because it was for the TRAPPIST-1 system coming out. It was embargoed. People were not supposed to be talking about these results. No one was supposed to know about it except for the team of researchers and the very small team of journalists covering it. And I knew about that like 3 weeks before it came out because of some rumors, some whispers I heard in a classroom with grad students. This wasn't even faculty talking. Like I know they were. It trickled down.
That's so funny. We need like the Dumois of astronomy. Like Dumois is the anonymous like blind items Instagram account where everyone sends in their celebrity encounters. And it's a lot to keep up with. I just check in now and then, but to have that for that's what I need for aliens.
I'll be your Dumois for aliens.
Yeah, you be my Dumois for aliens.
All right, so let's get into this search, the search for extraterrestrial life, or SETI as it's now known. Just quick up top, SETI, the search for extraterrestrial life, is distinct from the SETI Institute.
Oh, okay, because I was going to say I've heard of the SETI Institute.
Right, the SETI Institute does a lot of SETI work, but they are not the only people who do SETI work. People at NASA, other people funded by government agencies, they can do work in the search for extraterrestrial intelligence, even though they are not employed by the Institute.
Got it.
Yeah, so they are separate. But this is not a new thing. I feel like a lot of people assume that we've only recently started looking for aliens. It is only in the last 30 years or so that we knew there were planets outside of our solar system. But people have been thinking about the possibility of extraterrestrial life for thousands of years. We have evidence, we have writing from ancient societies, mostly Greek, because that's where a lot of the writing comes from, or like that's a lot of the writing that survived. But there were some Greeks like Metrodorus and Epicurus who separately wrote about why should we be the only ones here? If you look into ancient Greek philosophies, there was this one called atomism where they believed that everything, if you zoom out, was structured like an atom with a little nucleus in the middle and then things orbiting around it, like our sun in the middle and then planets orbiting around it. And they're like, why can't there be other little atomic solar systems like we have with their own planets? And if all of the molecules, they didn't have this language back then, but if all of the molecules to make life happened here, why can't they happen elsewhere? So this is not a new thing, but there were institutions back then that squashed thoughts of extraterrestrial life. Corinne, can you think of perhaps one very influential institution that might have squashed this thought?
Could it be the church?
It could be the church.
Could it be?
It's always the fucking Catholic Church.
Always the church. They're always doing something bad.
I know.
There's no fun.
I know. The Catholic Church, they were like, nah, everyone, we are the center of everything.
Yeah.
And if you say anything to the contrary, we're going to poison you.
Yeah, they're always like pulling their fists back, like really ready to fight.
They need one of their religious brethren to hold them back, like in a bar brawl. So a lot of this idea where we haven't been searching for extraterrestrial life, and a lot of people who say, well, there aren't aliens out there, I think a lot of that thinking comes from the church and how adamant they were that there was nothing else out there and that we were God's chosen people.
Of course. Yeah. It's all about control.
Of course. But then we had the Copernican revolution. We realized that the sun is the center of our solar system and not the Earth, and that the Earth is not the center of everything. We started looking at the other planets in our solar system through telescopes and gaining better observational data. We learned more about the nature of stars and planets, and we started thinking about aliens more scientifically. Which is where I get excited. That's
I'm sure.
Fast forward to 1960. We're going from ancient Greece to 1960.
It's a short leap. Yeah.
So 1960, according to what I found, was the first modern scientific search for extraterrestrial life. This project in 1960 was led by Frank Drake. If you are interested at all in alien science stuff, I'm sure you've heard the name Frank Drake because of the Drake equation. Have you heard of the Drake equation, Corinne?
I don't think I have.
Really? Oh, that's such a nice surprise. Well, we'll get to the Drake equation in a bit. But first, I want to talk about Frank Drake's Project Ozma, which was this first search for ET life. And he named it after the Queen of Oz, like from the Wizard of Oz. And he said he named it that because Oz was, and I quote, a place very far away, difficult to reach, and populated by exotic beings.
That is, if Oz is anything, it's that.
It's that. And he was like, yeah, I'm looking for a place far away with exotic beings, so let's name this Project Ozma. And I love Frank Drake. I'm so glad that he did this work. R.I.P. He died in September of 2022. And he did a lot of great work for astronomy. I'm saying a lot of nice things about him because I'm about to say something really mean. This project was so dumb. This project, I don't think makes any scientific sense given what we now know about space. So he took NRAO's, the National Radio Astronomy Observatory, which we talked about in the Light episode. Shout out to the radio quiet zone and my favorite region of the electromagnetic spectrum. So Drake was using NRAO's 85-foot antenna at the Green Bank Observatory, and he pointed the telescope at 2 sun-like stars for 6 hours a day for 3 months.
Okay.
Yes. So that telescope wasn't measuring like how much light we're getting from it. It was measuring the spectra of these stars. And we talked about spectra a little bit in the Light episode. But basically, he was trying to figure out what elements were in these stars.
Okay.
But he was specifically focused on one spectral line, the 1420 megahertz line. Megahertz is the frequency. And remember, we talked about how frequency and wavelength are very related. So 1420 megahertz corresponds to 21 centimeters in wavelength. And the 21 centimeter line is, for astronomers, a famous spectral line. We're nerdy enough to have famous spectral lines. But this line, this is the frequency or energy of the photon emitted by hydrogen in the interstellar medium. And Frank Drake was like, oh, we've discovered this interstellar hydrogen. We know that it's very important to astronomy. Any other sufficiently advanced civilization would also know about this line. And this is the jump. This is the leap that I don't appreciate. Just because they know about that emission line, they would use it as a hailing frequency. Like Frank Drake really thought that alien societies would all use the 21 centimeter line as a sort of communication code across alien species.
Certainly if we find it interesting, then they will too.
Exactly. Yeah. So I admire Frank Drake as a scientist, but he was definitely engaging in some some assumptions
over here.
Yes. Some assumptions were made that the way we do things is the way everyone is going to do things. And you'll see that play out a lot in this episode.
And this line doesn't correspond to what's necessary for what we define as life.
No, it does not.
Then what the heck are you doing, man?
Hydrogen is the most abundant element in the universe. So when we're looking in the interstellar medium, in the place between stars, we see a lot of hydrogen gas. So it's one of the more common lines that we study.
So how does it narrow the field down in any way?
I don't know. The fact that he picked two stars out of the hundreds of billions in our galaxy to look at, and
he was getting paid by Big Star.
Oh, that's actually a oh, I wish. Speaking of money, though, because he only used existing equipment and he didn't have other labor, he was just doing this work himself because he was passionate about it, the project only cost $2,000.
What?
Mm-hmm.
In modern time.
In modern time, well, in 1960, it cost $2,000 for him to operate this telescope.
Fun that.
I know, right? Because he didn't This was a really controversial topic. The public didn't believe in aliens. The public didn't believe that that government funding should be put towards this type of research.
Okay.
The public is always so worried about what federal funding is going towards and never paying attention to the military.
I was just going to say, well, I learned when I was at the Space Center that the New York City Department of Ed has a bigger budget than NASA.
Yeah. NASA's budget is a tiny drop in the bucket.
It's so tiny.
Mm-hmm. Maybe we should do an episode about NASA budgets
That
sometime.
would be fun.
So it was a very cheap project. He wasn't trying to enrage the public. And that was in 1960. And then about 15 years later, in 1974, Drake crafted the Arecibo message. Have you heard of this?
I don't think so.
So the Arecibo telescope, may it rest in peace, may it rest in power, actually.
Yeah.
Was a huge satellite dish in Puerto Rico that was used to send a message with information about Earth and humankind to a globular cluster, which is this little collection of stars in the halo of the Milky Way galaxy. And Frank Drake crafted that message, and then we sent these short pulses of radio signal to transmit this message out into space.
Whoa. So the message is just like signals, or is it like language?
It's signals.
Okay.
So one of the goals for the Arecibo message was to just show how powerful the telescope was and the transmitter was that was sending this signal. And it's waves. It's a wave packet, but they figured out how to take information about our DNA and our position in space and put it into wave form so that it can be hopefully interpreted by whoever receives the signal. And it was aimed at the globular cluster M13. But by the time the light waves actually reach that space, M13 won't be there anymore.
Oh.
So it will have moved. Maybe something else will be there instead. But
whoa!
So a lot of people were mad. They're like, "Why are you sending out this signal? If someone finds it, they might come to us. So you're putting us in danger." But the chances of someone actually receiving that signal are very, very low. And they mostly were just using it to see how powerful the transmitter at Arecibo was.
Okay.
So that was 1974. This is now decades of Frank Drake and other people involved in the search for extraterrestrial intelligence repeatedly hearing from the public, we don't like what you do, we don't want to fund it, we don't want you sending out these messages. And the U.S. government was hearing that and stopped funding through the normal channels to get this research done. So in 1984, some of these SETI astronomers got together and decided to start their own nonprofit called the SETI Institute.
SETI Institute, there it is.
And now we're finally at SETI. It's a nonprofit organization that began operating in 1985. Its first officers were Thomas Pearson, who was a business admin person, and Dr. Jill Tarter, a woman after my own heart, who was one of the lead SETI science researchers there. Early trustees included Frank Drake, of course, and Carl Sagan, who was nice enough to give us the name of this podcast.
Yes.
So the SETI Institute. I'm going to try and be very careful about that throughout this episode. The SETI Institute's goal, when it was incorporated, was to focus on research and education around the factors of the Drake equation. So now we have to get into what the Drake equation is.
Here we are.
You've really never heard of this?
I think maybe I have. I'm looking at our notes and it's ringing a bell. But again, the alien stuff I was into was the farmers who have been abducted. It's not the actual science facts of aliens. I'm just here for the late night trip to the bathroom where you never return.
Great. Maybe get your belly button poked a little bit.
Yeah, exactly.
I love how we're coming at this from two
very different angles.
Maybe, perhaps, like the aliens probing your belly button. I like to think that they would approach it from the front and the back. That's how I would do it if I was an alien.
Well, they would be curious. I'm like, is there something on the back now?
Right. What happens if we meet in the middle?
I just can't imagine poking something I've never seen before. I just think I would stand far away and be like, I don't know about that.
Therein lies the difference between us, Corinne. I'm poking everything.
That's the line.
I'm trying to hold myself back from licking every foreign object I see.
You're going to go out there and poke it and report back to me, which is the whole dynamic here anyway.
Corinne, I'm going to go lick it and report back to you.
Perfect.
So this Drake equation was not from one single mind. Let's get rid of the idea of the lone scientific genius doing all the work on their own. Instead, this Drake equation, even though it's named after Frank Drake, was agreed upon at a meeting with a lot of astronomers in 1961. And the Drake equation itself is this long list of factors or coefficients, if you remember that word from high school math class.
I do.
Flashbacks, right? So it's a long list of factors or coefficients that represent the steps towards an intelligent species or civilization. And when you multiply all of these factors together, you get the number of transmitting extraterrestrial societies.
Okay.
So these there are 7 of these factors, and n, the number of like transmitting societies, equals. I'm going to say all the letters out loud, and then I'll tell you what they mean. So n equals r star times fp times ne times fl times fi times fc times l.
Okay. Couldn't tell
I love
you.
that this is an audio medium. Like, really, it's
Everyone got that?
Everyone got that? Well, okay, now I'll tell you what it is. All right, so this number of transmitting species, the first coefficient starts with R star, which is the formation rate of suitable stars, of stars that could like lead to life. That's pretty much all stars, except we do know that the most massive stars, like the O and B stars, we should also do an episode on stellar types. That's in the works for the future.
Wow.
But these very, very hot stars don't live long enough for life to form.
Okay.
They live about like 10 to maybe 100 million years. And we know on Earth, at least, it took 1 or 2 billion years for life to develop. Okay, so that's the formation rate of suitable stars, which again is most types of stars. And in the Milky Way galaxy, for example, we probably form about 5 to 10 stars a year of various masses.
Wow, that's good for us.
I know, right? we form like a couple solar masses worth of stars every year, but you have to remember that most stars are much less massive than the sun. So It's not like we're only making one sun-like star every year. Okay, so that's the R star. The next factor is the FP, and that is the fraction of stars with planets.
Okay.
That makes sense, right? So you're looking for the number of stars that form, and then you're only interested in the fraction of those stars that have planets. Even more specifically, you're interested in the fraction of those stars with planets around them, but those planets have to be habitable. So that third coefficient, the NE, is the number of potentially habitable planets per system.
Mm-hmm. That makes sense.
That makes sense, but there are a lot of assumptions going into this.
Okay.
Keep that in mind. So that's the number of potentially habitable planets. And then you multiply that again by the fraction of planets where life appears. And then the fraction of those planets where the life becomes intelligent. Mm-hmm. And then the fraction of those planets where the intelligent life creates or invents detectable technology.
Okay.
And then you have to multiply all of this by L, which is the average length of time that a civilization survives at that technological level.
Oh, okay. Wait, how long is it? How long do we have?
Well, I mean, what the SETI Institute does is try to constrain the values of each of these coefficients.
Okay.
Like, we still aren't totally sure what the star formation rate is. We still aren't totally sure how many planets there should be in a system, like on average. And we aren't sure how common life is, or once there is life, how common is intelligence? Like, we don't know these things, and that's what the SETI Institute is trying to figure out.
Yeah.
But this L factor is interesting because that brings in the idea that a civilization might be destroyed.
Yeah.
This brings in philosophical questions like, is the end of a civilization inevitable as they continue to advance technologically? And there have been so many sci-fi stories or so many like short little thought experiments about this. Mm-hmm. So I think the L factor there is really important. And
yeah, that's really catching me too.
Because I think it's of all of these factors, it's the one that relates to us the most.
Yes. I'm like, immediately I'm like, how long do I have?
Exactly. It creates that existential dread. we don't know. We have no way of knowing. But I'm choosing to be optimistic. I think a lot of people, when they start thinking about the average duration of an intelligent society, they start thinking maybe about the Fermi Paradox. Have you heard of this?
Yes, I have heard of Fermi's Paradox.
Yes. So Fermi's Paradox is like, if there are all of these planets in the galaxy and we think that life is probably pretty common, where are all the aliens? Why haven't we found them? Why haven't they made contact? Okay, so there are a lot of reasons. There are a lot of reasons not to fall into the trap of the Fermi Paradox. For one, space is really big. If people are traveling and they don't have faster than light technology, like if that truly is not possible, then it's going to take a society time to spread around the galaxy. But maybe it's also just expensive to travel around the galaxy, or maybe it's logistically difficult, or maybe the galaxy is filled with hostile aliens that prevent any sort of spreading of societies, or maybe
they visited us in the Midwest one night and they met that man, and he said they were like, I don't think we want to be here, and they put him back, and they
right. That is a common response to the Fermi Paradox, which is like, maybe we're just being ignored. Maybe the aliens came by, saw that we ain't shit,
they're like,
and decided to leave.
I don't want a piece of that. Continue as you were.
So there are lots of reasons not to fall into the Fermi trap. I think that just because we haven't detected aliens doesn't mean they aren't out there, and it doesn't mean that these societies are short-lived. Because that's the thing, right? Like, without the L factor there, the number of transmitting societies that we get from the Drake equation should be fairly high. And so people think that L factor is what is making it so we aren't seeing any aliens, because they don't live long enough for us to see them. And then they get worried about us. They're like, well, we know we're intelligent and we have technology, but what if we just don't live long enough?
Right.
What if we don't last long enough? So yeah, I don't really have any comforting words for you there other than we seem to be doing fine. I mean, like, I know we joke about how the world is on fire, and yes, the oceans did literally catch on fire a couple years ago, but that's because of stuff that we know how to fix. Like, we can fix it.
Yeah.
I believe in us.
I'm looking over at my TV, and I'm like, or the TV's in the salon, and I'm like, they're gonna just sprout arms and legs and kill us all. Which is clearly not what we mean by technological, like, death. But it's what my brain is going to. I'm like, great, everything around me is going to grow a little face and stab me in the night.
Corinne, that's terrifying.
Yeah, this is where my brain goes. This is what's captivated me. Okay, well, I don't think it's going to happen.
No.
Or at least we have a few years.
You're not being very comforting, Corinne. No.
And neither is Moiya.
That's true. Okay, let me try and be a little bit comforting. I don't think the technology is going to grow a face and attack us. Usually when they talk about technology leading to the end of a civilization, they mean the energy use that is required to power a technologically advanced civilization might be... You might need more energy for that than is available.
Got it.
So we can imagine ways that a society might overuse some of its resources to generate power for itself. We are at the start.
We're doing it now.
We're in the stages of that now, but we know how to fix it. Science and science fiction have given us a lot of ideas for how to fix this problem of ours, and I do believe we can do it.
Let's do it.
And even if we're the first alien race to do that, like, great. I'll take that first.
Sure.
I'll take that win.
That would be amazing.
So this is all about the Fermi Paradox, but there's a kind of cute story about how this paradox originated. So it's named the Fermi Paradox after Enrico Fermi, or Fermi, who was a Nobel Prize winning physicist who was very involved with the Manhattan Project and the and the bombs. Like, he figured out how to do nuclear fusion for us. And then World War II happened. So thank you, Enrico Fermi.
Thanks, Fermi.
Thanks. So in 1950, Enrico Fermi was having lunch with his colleagues at Los Alamos National Lab in New Mexico. And kind of just like under his breath, they weren't really talking about SETI specifically, but under his breath, he muttered, "Where is everybody?" And in the letters that I read, they said that it was clear he was talking about aliens. But then he did not go on to actually flesh out this
Oh my
Fermi's
gosh.
Paradox. Like Fermi died a few years later. And then it was other people who remembered this conversation or who did their own calculations that talked about how easy it should be for societies to spread around the galaxy given how long the universe has been around. Even if it takes you 1 million years to reach a new star because you can't travel close to the speed of light, the galaxy has been around for billions of years. So they should still have time to spread.
Oh, that's so fun. I would love to just say something offhand and then it becomes like a key piece of science.
Right? Maybe I should just have people following me around at all of my lunches, writing down my little offhand remarks.
You should just be muttering all the time.
All the time. And then just totally rock the scientific community with it. Yeah. Yes, please. I would like that. That's Fermi's Paradox. There are lots of reasons you don't have to fall into that trap. We know that there are hundreds of billions of stars in our galaxy. On average, all of those stars should have a couple planets. So there are many hundreds of billions of planets in our galaxy. And who's to say that life can only exist on planets that look exactly like Earth?
So true.
Why? Why would it?
Why would it?
Yeah.
Hey, it's Corinne. Here's a quick shout out to some of our amazing patrons who are supporting this podcast. Thank you, as always, to our sun-like stars, Sharn Llewellyn and Finn, and thank you to our latest pre-main sequence stars, Three's the Charm, Ileana Lado, and Shannon Henderson. You too can support us, hear your name on this podcast, and make it to our patron star chart, all by supporting us on Patreon. Find the star chart, Patreon info, and more at our website, palebluepod.com, or by going right to patreon.com/palebluepod.
I know I'm already a doctor of the universe, and I learned a lot of the stuff that we cover on this pod in school, both undergrad and graduate. But I still have to do a lot of research for these episodes, if only to make sure that what I think I remember is accurate. So I spend so much time on the internet, like I'm sure all of you. I open new tabs at a rate that might actually be a little bit alarming, but luckily I know of a way to turn that tab opening into something good for the world. I use Tab for a Cause. It's a browser extension that lets you raise money for charity while doing your thing online. So whenever you open a new tab, you'll see a beautiful photo and a small ad. And part of that ad money goes towards a charity of your choice. You can join the team for Pale Blue Pod by signing up at tabforacause.org/palebluepod. That's Tab for a Cause, TABFORACAUSE.org/palebluepod. And I hope you know how to spell the name of this show that you're listening to right now. So browse the internet and make good stuff happen for the world. You can even choose charities that you want to support. Again, that's tabforacause.org/palebluepod.
I just wanted to let you know that if you like Pale Blue Pod, then you might love Star Tripper. It's a travelogue podcast about former file clerk Festin Pixis as he searches for the zowiest experiences the galaxy has to offer. In the tradition of classic sci-fi, anime, with a little bit of Saturday morning cartoons sprinkled in, dive into the action and explore the thriving cosmos with Festin and his crew. You can listen as they zoom through an intergalactic death race, battle a mega beetle live on a popular cooking show, and navigate their way through the eerie dunes of the packaged dimension. Star Tripper has a fully immersive sound design, killer music, and is an instant mood lifter. Popular Science even called Star Tripper pure joy in a zippy little sci-fi package. 2 complete seasons and 2 Space Holiday specials are available to listen now wherever you get your podcasts and on Star Tripper's website, startripperhq.com.
Hi, it's Moiya. Can I interest you in a podcast recommendation? I'm just going to go ahead and do it. This one is coming from the Multitude Collective, and it's called Games and Feelings. Games and Feelings is an advice podcast all about games, appropriately. You can join Question Keeper Eric Silver and a revolving cast of guests as they answer your questions at the intersection of fun and humanity, since, you know, you gotta play games with other people. And we're talking all types of games here. Video games, tabletop games, party games, laser tag, escape rooms, even game streams and D&D podcasts, and the people and companies that make these games. Really anything related to something that you might play. So they'll ask questions like, Like, how do you convince people who have only played Monopoly to play the new board game that you grabbed at the game store? Or is an escape room a good third date? If these topics sound interesting to you and if you like to play things, then why don't you level up your emotional intelligence stat and subscribe now wherever you get your podcasts to Games and Feelings. New episodes come out every single Friday. So I think I need to tell you what types of information we can learn about exoplanets before I tell you, like, how we're actively searching for the aliens.
Yes.
Because all of this so far has been, the history of, do people think aliens are out there? And now we can actually start talking about how people are looking for them now that most scientists would agree, yes, they are out there. We just need to find them.
Okay.
So we will definitely be doing at least one episode in the future about exoplanet detection methods, because that is my shit. I would not need to do any prep for that episode. That'd be really nice.
Moiya Exoplanet McTier.
You joke, Corinne, but
it's true.
Maybe I've changed my middle names legally to exoplanet. So we'll definitely do that episode or episodes later. But the information that will be helpful to you right now is that we can only observe or directly measure a few pieces of data about a planet outside of our solar system. We can measure how big the planet is, like its physical size, its radius. We can also measure its mass. We can figure out how far away the planet is from its star, which gives us an idea about how hot or cold the planet might be, as long as we also know how hot the star is. But that's like an estimate because we don't know what's going on inside the planet. We might have some basic information about the planet's atmosphere if it's big enough, thanks to spectroscopy. And we might have an idea about how shiny or how reflective the planet is. Astronomers call that albedo. And you can do this by measuring how much light you're getting from the planet as it's rotating around. If you're getting a lot of light from the planet specifically, it's a shiny planet and there might be ice on its surface. If you're not getting a lot of light from this planet, then it's probably not very reflective and maybe there's just like a lot of dirt. Scientists do have lists of the reflectivity of different substances like trees, dirt, water, ice, and it's really cool.
That's so cool. I love how much you're showing me that's a lot of, especially in astronomy, it's deductive. If this is true, then this is true. And I mean, that's how I solve problems in day-to-day life all the time. So it's just so fun to see it on a large scale because science can feel so untouchable and especially to a science that is literally untouchable, like astronomy. I say all the time, I can't touch a star, but I study stars around the galaxy. Astronomy is fundamentally an observational science. We can't run experiments. We can only make control groups out of observing enough stuff out in the universe. So we do have to do creative deductive reasoning work to learn about space. I love it.
All of those things that we can learn about planets, they come from different planet detection methods. So we'll be talking about that in the future episode. But that list, size, mass, distance from star, some information about the atmosphere and how shiny the surface is. And then in the future, I did a project in grad school where I came up with a method to figure out how bumpy a planet is. We can't do that with current technology, but soon we will also be able to, I say soon, in the next 10 to 15 years, we'll also be able to learn about the surface features of planets.
That's so fun.
Thanks to my work.
Yay! Thanks to your muttering at lunch.
Yes, exactly. Actually, one of my projects in grad school did happen because one of my advisors had a random shower thought, and then he came into work after that shower and he was like, "Hey, Moiya, have you ever thought of this?"
That's so fun.
I was like, "No, but let me spend the 4th year of grad school answering this question."
That's amazing.
And I did. That's a true story. But that list of things that we can learn, that's all we know about planets. So anytime you hear someone on the news say that we've found an Earth-like planet or that we've found a planet that is habitable, take that with many grains of salt. Be pretty skeptical about that because we don't have the ability right now with our current technology to learn much about these individual planets.
Okay.
So we're making a lot of assumptions when we make claims of habitability. But with those things that we can learn, scientists have gotten very creative in manipulating those pieces of data to try and eke out any sort of information about the existence of life on that planet. Broadly speaking, the two types of evidence that astronomers are looking for when we're searching for life, when we're doing this SETI work, are technosignatures and biosignatures.
Okay.
Technosignatures are signatures of technology existing on that world, and biosignatures are signatures of life existing on that world. Remember that one of the factors in Drake's equation was the fraction of intelligent life that produces, and in my notes, this is in italics, detectable technology. So the technology part was always really important to the SETI Institute from the beginning, from its incorporation. Researchers, scientists, and science fiction writers, they've done a lot for this work, have gotten creative when imagining what that technology could be that aliens produce. And then the scientists who, like the astronomers who are looking for these technosignatures, have had to get extremely creative in figuring out how to find it. So some things that, some like pieces of technology that we might be looking for are lights that they use during nighttime, or maybe some sort of big structure, like a big spaceship that they build outside of their world, or maybe they are, like we did with the Arecibo message, maybe they're also transmitting something. So we're looking for these short bursts. But each of those pieces of technology has like a different way that we would try to find it. Most of these are by trying to measure how much light you get from the planet and the star, and based on like the change in light over time, figuring out what created that light. So one of my favorite technosignature papers that I ever read was by, I'm not going to name the author because he sucks, but the paper was interesting. They were looking for nightlife on exoplanets.
That's
like they were
so
imagining
fun.
these aliens going out and clubbing.
Yes.
Like they are picturing an alien Manhattan, and I love it.
And that's what we're looking for. I'm only going there if they're cool. And if they have city life.
If I can club, I'm going. So as the planet orbits the star, the planet itself will block some of the star's light. If it's between us and the star. That's normal. We search for planets using that method all the time. It's called transit photometry, and I will absolutely nerd out about it in a future episode. But for now, for the searching for nightlife, as the planet goes around the star, it's also rotating because planets orbit and they rotate. We have a year on Earth, and we also have a day on Earth. If we can see the night side of the planet, like when the planet is between us and the star, we are looking at the night side. If that night side is brighter than it should be, based on the light that we've been measuring from the system over time, if the night side just looks bright, we would say they have some night lights.
They have night life.
they have. That's a roaring city right there. Or so I talked about megastructures. These alien megastructures is a term that gets thrown around a lot. One of the most famous of these megastructures is called a Dyson sphere. Have you heard of these?
No, but I'm picturing a Dyson vacuum, which can't be right.
You know, it's not that far off. I think the Dyson vacuums have like a sphere that rotates, and that's part of the suction.
Right.
I don't think that's not why
Might not be part
they're
of it,
named that.
I can remember it that way.
But the idea is that if a civilization gets so technologically advanced, they would need more power, but they might not have enough energy on their planet. So what they would start to do is harness the energy of their star. So a Dyson sphere is this hypothetical thing. It was, I think, maybe first or like early on, it was talked about in science fiction. The Dyson sphere would be this structure that they build around their star of like solar panels to capture energy and then funnel it towards their technology.
Whoa.
And we would be able to detect that if because the sphere itself would heat up. It would collect energy from the star. It would block the star's light if it's opaque. But then it would heat up and emit in the infrared part of the spectrum. So we would be able to detect that. And I just love how creative we can get with like not just the wavelength that we're observing in. Like you can see different things if you observe in the optical versus the infrared. We talked about that in the light episode. But also like the shapes of the signals you're looking for.
That's really cool.
There are so many ways to look for technosignatures, and I'm just really happy that we have that. So the government, the U.S. federal government has recently become more interested in funding technosignature research. So now people at NASA, people at federal labs, people at universities that are funded by the government, they are now getting to do more technosignature research. But it's also being funded pretty heavily by private people, like by the private sector. I think the biggest funding for technosignature research right now from the private sector is coming from the Breakthrough Listen program. Breakthrough in general is this series of projects aimed at finding aliens, pretty much. It's funded by Yuri Milner, Yuri and Julia, his wife Milner. And they gave $100 million to not all of Breakthrough, just Breakthrough Listen.
Wow.
Got $100 million paid out over 10 years to look for technosignatures specifically.
That's really cool.
I know. He's putting so much money into this.
That is so much money. Especially when Drake did it. It was Drake, right? Who did it for $2,000?
Yeah, but he was also looking at 2 stars.
Yeah, different thing, but so funny how we've made the leap from $2,000 to $10 million a year for 10 years.
I know. What would Frank Drake have done?
Oh my God, he would have pointed it at 3 stars.
You're right.
Maybe 4.
Again, R.I.P.
Yeah.
But 2 stars? What the fuck? Okay, so that's technosignatures. Very similar, but distinct, is the search for biosignatures. These are signs of biological processes on a planet instead of technical ones. So we're not looking for light that they created. We're not looking for any big megastructures. We're looking for stuff that just happens in their bodies. So we have studied chemical reactions here on Earth well enough to know that there are some molecules, there are some compounds that only exist where there is life because natural processes don't produce it or don't produce it in high enough quantities to be measured.
Okay.
And then the leap there is that if they detect those types of compounds on other planets, they would expect that natural processes on those planets work the same way. So they aren't producing these molecules naturally, but are producing them in alien bodies.
Okay.
Some of these molecules are oxygen, methane, nitrous oxide, dimethyl sulfide. A couple years ago, there was this big story about astronomers thinking that they found, it turned out not to be true, but they thought they found phosphine on Venus, which is a biosignature because it's very related to aerobic digestive processes.
Oh.
You find them a lot in garbage dumps here on Earth where there are bacteria producing that. And that's not to say that these molecules don't exist without life. We know that there's oxygen around, there's methane around, but only life can produce it on Earth at high enough levels that we would expect to detect it in an exoplanet. And again, we are making assumptions about the biological processes of those aliens and also the natural processes of those planets.
Right.
I don't know if we can be 100% certain that the chemical reactions would work just the same way on those other planets. They might have drastically different conditions, very different temperatures and pressures. So who knows? Yeah,
we're really assuming that what we're going to find is a human or something close to what we have here on Earth, and who knows what we don't know.
Yeah, I like to be very generous and say that astronomers know life out there wouldn't look like us, but we are trying to constrain our search to make it easier for us. We're looking for things that we know produced some type of life.
Yeah.
And we are the type of life that we know best.
Yeah.
So these biosignature searches rely less on light, like the technosignature searches, and more on spectroscopy, more on measuring the elements that you would see in a planet's atmosphere. But there are some light things you can do. If you have... I remember seeing this paper about algae blooms. If you have a lake or something that has algae in it, it will bloom seasonally, when the planet is in different conditions. So we can measure the color of the planet over time. And if it's green some parts of the year and not green other parts of the year, we're algae.
That's so funny.
Or if we can see, this is very similar, if we can see seasonal changes in albedo. Remember, albedo is how reflective the surface of the planet is. So if it's very reflective part of the year and very absorptive not very reflective the other part of the year, then maybe ice is melting.
I was just going to say, is that ice melting?
Yeah, it's ice melting, or it's trees like blooming and then dying. So we look for that a lot. And these biosignatures searches are much easier to do in our own solar system.
Sure.
Because the planets are closer. Some of the planets we can actually send stuff to. So the rovers and other machines on Mars are searching through those rocks. Like some of them have instruments on board to look for organic compounds and molecules. The Cassini spacecraft that we sent to Saturn and its moons flew through these jets of water that shoot out of one of Saturn's moons called Enceladus. And I'm pretty sure we knew already that moon, Enceladus, had an icy surface, but liquid water underneath that icy sheet. And we sent Cassini flying through one of those jets of water, and it analyzed the water. And what we found was like a mixture of organic compounds and delicious saltiness that might lead to life. And we have this mission that will be flying on Titan, another moon of Saturn, flying through its atmosphere. The mission is called Dragonfly because it will look like a little dragonfly just hovering through the atmosphere of Titan, and it's going to be collecting samples to see if there are organic compounds there.
Oh, that's so fun.
So yeah, we are actively searching for stuff in our solar system. Enceladus is something that astronomers are excited about. Europa, which is one of the moons of Jupiter, it also has this icy sheet covering a liquid water ocean underneath. People are excited about that, and people are very excited about Dragonfly on Titan.
That's so cool. I had no idea about the plumes of water even.
I know. It's just like Old Faithful, but out in space.
Yeah. It feels so normal and like very earthy.
Yeah, Corinne, you can find elements of Earth everywhere else in the universe.
I love it.
It's the same stuff, just arranged in different ways.
That's amazing.
This is a bit of a tangent. I read Come As You Are by Emily Nagoski earlier this year. And one of the things she really focuses on in the early chapters is it's all about like bodies and sexual pleasure. And one of the things she says over and over again is that all of our bodies are just the same parts, but rearranged differently. Like even across genders, like everything, you know? And I like to think of space the same way. Like everything is the same parts. It's just arranged differently.
That's really fun. It feels like a Lego thing of like, I can use these pieces and make it in this way now.
Yes, exactly.
Well, I do have a funtivity for us about aliens, and this is way closer to how I think of aliens.
Oh, good.
So it makes perfect. It's perfectly fine if this is challenging. It is a series of true-false questions about the movie Alien.
I've never seen it, so this will be fun.
Moiya? Neither have I.
No!
I think I may have seen it at my friend Chelsea's house a few years ago, but I don't remember if that's what we watched. We watched a few movies that night, but okay. Let's see. Alien, the movie. Okay, well, I'll give you a brief overview of what Alien is. It's a movie starring Sigourney Weaver and an alien. There's more to it than that, but that is what I know about it for sure.
Good. I'm going in with this much information. I'm so prepared.
True, false. Alien, the movie is a 1979 film directed by Ridley Scott.
Oh, shit. Okay. So the thing about true, false quizzes is that usually it's in the details. So like I could say true, but you're like, no, it's 1978
right.
or 1973
I'm gonna
or something.
say though that when I wrote these, I didn't try to trick you.
Okay. Okay, good. I'm pretty sure that's true.
It is true.
Yay! Corinne, just a fun thing about Ridley Scott. My favorite commercial ever is a 7-minute commercial directed by Ridley Scott for Hennessy.
I've never heard of this.
For Hennessy XO. And their whole thing is like exploring the different worlds, which represent the different flavor notes in Hennessy XO.
Oh my God, that's so fun.
I have watched this 7-minute commercial so many times.
Okay, I'm gonna watch this as soon as we're done.
Please do. So that's what I know about Ridley Scott, and now I know he directed Alien.
Okay, next true false. Alien the movie was met with mixed reviews on release, but was a box office success.
I'm gonna say false. I don't know why.
It's true.
It's true? It's true.
It was met with mixed reviews, but it was a box office success.
I was like, maybe it was met with great reviews, but it failed at the box office. Because that happens sometimes.
That happens a lot. Mm-hmm. Well, luckily, Alien, success. Okay.
Great. Good job. Well, that explains
Alien.
why there are so many movies in the franchise.
Many of them. I don't think I asked you about how many there are, but there are many of them.
Mm-hmm.
Okay. Alien the movie was deemed culturally, historically, or aesthetically significant by the Library of Congress.
I refuse to believe that's true.
It is true.
Corinne, are all of these true?
Yeah, well, I'm pretty sure.
Is this just a true quiz?
I am pretty sure they're all true. I think there's one that, okay, there's one that might be false coming up, but it's just so deductive. Now you're going to know. Okay, well, here's the next one. The alien in the movie Alien has a full set of human teeth like a real man.
No.
True.
I know they're called xenomorphs.
Are they? I didn't even know that.
I know they erupt from your belly.
Oh my God, they do?
They have human teeth? Why do they have human teeth?
Well, I don't know if they're human teeth. Clearly he owns his teeth.
Wait, Corinne,
but...
that was a key word in the question.
Well, I wrote the questions and I picked the answers in this unscientific way. So to me, he has human teeth like a real man.
Okay, so the question should have been true, false. I, Corinne, think that this alien has human teeth.
Okay, that's it. That's the question. Okay, next question. The movie Alien's writer, Dan O'Brien, also worked on Star Wars.
False.
True.
Damn it, Corinne. I'm going to say false for everything.
He did computer animation and graphic displays in the miniature and optical effects unit the year before Alien came out.
Oh.
I thought that was cool.
Okay, I can see the overlap there. Lots of sciencey effects needed. Mm-hmm.
It was probably a smaller world too of like the sci-fi movie industry, I imagine.
That's true. Everyone knows everyone. They're like, "Hey, you want to hire Jim over there?
Yes.
He's just one lot over."
Just go get him. I think he rapped on his other thing. Okay, last one. It's not false.
Thanks, 'cause I actually have been sitting here like
I'm like, where's the false one?
Well, that too, like with little raccoon hands, but also the like perfectionist A+ student in me is like,
I gotta get it right.
So many wrong.
No, you're doing great. This is made up. Actually, the best score you can get is a 50%. So. Okay. In 2019, students at North Bergen High School in New Jersey adapted the film into a play.
I know it's true, and I need to know so much more about this. How did they do the eruption?
That's such a good question. I don't know about the like how they did any of the effects, but Ridley Scott found out about it, was so like excited, he paid for them to do an encore of the show, and Sigourney Weaver attended it.
Did Ridley Scott attend it?
I don't think he did. Well, at least the Wikipedia didn't say that he did, but maybe they didn't care if he went, and it was like way more remarkable that Sigourney Weaver went.
Yeah, she's remarkable.
But there is a stage adaptation of this that a high school did, and Sigourney Weaver's seen it.
I love that so much.
And that concludes the Alien game.
Wow, what a lovely game where the questions were a bit misleading.
Are made up. In the same way, we don't know much about aliens. We don't know much about how to write a quiz.
Exactly. Yes, we're not a quiz podcast.
You can't be good at everything.
That's true. That's true. You know what? I firmly believe that you cannot be good at everything, and you should not.
We should be dividing it up.
It's unfair.
Yes.
Yeah.
It would be really rude of me, actually.
Leave some awesomeness for the rest of us, Corinne, please. Well, that is perfect timing that we just finished this quiz, and my deep conditioning treatment is done. I feel steamed. My hair is so moisturized, and these curls are gonna be popping. I can already tell.
Birthday curls. Let's go hit up some alien nightlife.
Let's go clubbing on an exoplanet.
Yes.
And we'll know which ones have the good clubs based on their nightlife profile. That's really hard to say. That's
a mouthful.
Yeah.
That's how I'm going to warm up for the next episode.
So, listeners, wherever you are, whatever your hair looks like, remember that you are space.
Bye.
Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.